Okay, 5.3, I know we already did this in class, but here is your video for population ecology. A population, again, is a group of organisms of the same species, and they're living in the same place. When we're talking about population density, that's how many individuals we have in that specific space. We can have more dense population from high birth rate, immigration, which means organisms coming into an area, and then density is reduced by death, or emigration, which is the opposite, so organisms leaving the area. Something really dense would be a lot of individuals in a confined space, and low population density would mean not that many individuals in a defined space, so more spread out. We have something called survivorship curves. The MCAS likes to bring a lot of graphs, so definitely be familiar with these. It's a graphic representation of mortality patterns, and it's going to show the number of individuals in a population that can be expected to survive, like age expectancy. So type 1 is like humans, so they live for a while and then they all kind of have an average lifespan. Late loss, heavy parental care. Type 2 would be constant loss. So birds and rodents are good examples. They're prey to other predators. So they may not just be aging or getting sick, they may be getting preyed upon. Type 3 is early loss. So an organism that creates a lot of offspring and not many survive. So fish would be a good example of that. And remember, I told you the Finding Nemo example, kind of sad. But it's true, fish lay a lot of eggs and not all of them survive. Dispersion is the distribution of organisms in a population. So it could be random, it could be uniform, and it could be clumped. So when I look at these, I think about certain towns or certain areas of the country, like clumped might be the Midwest. Uniform and even may be like a city or even like a condominium complex where they all kind of look the same and they're all kind of evenly distributed. And then as far as random goes, I mean, I don't really think of any specific place, but I'm sure there's plenty of examples out there. Population growth could be exponential, so it's growing without limits. Humans are doing this. They're actually starting to slow down a little bit, but in general, if we were running out of food in one area, we just get it from another area. Logistic the population will grow quickly and then it'll level off based on the environment. Most natural populations follow this. And this dotted line is showing the carrying capacity, so this is theoretically how much the environment can support. So think of food, think of water, think of habitats. So limiting factors, they limit how much a population can grow. And these factors can be living, which would be biotic, or non-living, which would be abiotic. And we definitely talked about plenty of examples in class. So a biotic limiting factor could be disease. An abiotic limiting factor could be climate. These factors can also be density dependent or density independent. So if they're density dependent, they have a greater effect on population, how much it'll limit it, based on how many organisms are in an area. So density dependent have a greater impact on dense populations. Think of like a city. We're thinking about crowding. So competition for resources. The more individuals there are in an area, the more that this is going to affect the population. So if there's not a lot of food, but there's not a lot of individuals, it's not going to matter too much. But if there's not a lot of food and there's a bunch of individuals, that's going to seriously bring the death rate up. There's predation, parasitism, disease is another great example. So when COVID was going on, it had a greater effect on large cities than it did on less dense populations. Now, density independent will have an effect on the population regardless if it's dense or not. So it's going to affect everybody equally, or every type of population equally. So a natural disaster like a tornado, it's not going to bring more damage if there's less or more people. It's going to essentially do what it's going to do regardless. So a disease stops spreading when there's not as many individuals, but a tornado is going to run through where it's going to run through regardless. Same thing with pollution and weather changes. That's the end. Make sure you have your packet done, packet 1.